the question here says, given the geometric series 5/8 plus 5/16 plus 5/32 plus dot equal to k, determine the value of k if the series has 21 terms. Now, I am going to write the question here, 2.2. So we have terms like 5/16 plus 5/8, 5/8 plus 5/16 plus 5/32 plus dot equal to k. Now, question 2.2.1. The question here says that determine the value of k if the series has 21 terms. Okay, so we're looking for k if n is equal to 21. N determines the number of terms. So basically, k over here is just equal to k is just S21. Okay, so meaning we're looking for the sum of these terms, 5/8 plus etc. up to 21 terms. Now we know that the sum Sn is given by a open brackets 1 minus r to the n close brackets over 1 minus r, or sometimes they write like this: Sn is a r to the n minus 1 over 1 r minus 1. Now I prefer to use this one when r is between -1 and 1. Okay, and let's just find the value of r. You know that r is given by Tn over Tn minus 1. So it's a term over the previous term. Then let's find r. It's gonna be if I take like 5/16 over 5/8 over 5/8, this will be 5/16 multiplied by 8/5, which is equal to okay, we can simplify here 5, and then there also 2. So this will be equal to 1/2. Then therefore we can say S21, okay, Sn will be equal to a, which is the first term, 5/8, and then I prefer to use square bracket 1 minus 1/2 r to the power of n all over 1 minus 1/2. So doing 21 terms, S at sub n by 21. Then we can use a calculator to find this. If we can just write this as this in the calculator, so I'm gonna say there 5/8, okay, and then open brackets 1 minus open brackets 1/2, okay, close bracket to the power of 21, okay, and then we're going to close brackets over 1 minus 1/2, and then it's equal. This means the answer is 1,2499. Now we're going to run to the second decimal place. So because of that, we're going to look at the third decimal value. And because the third decimal value here is 9, it is more than 5, we're going to increase the previous term here, the second decimal value, by 1 unit, so maybe 25. So S21 is just equal to 1.25. So therefore, k equal to 1.25. That's 2.2.1. Now we're going to do 2.2.2. I'm going to move my board over here. Let's see 2.2.2. Over here, the question says determine the largest value of n for which Tn is greater than 5/8192. So now moving on type is we are looking for n. We're looking for n. If Tn is greater than 5,000 over 8192. Now, okay, Tn itself is given by ar to the power of n minus 1. Okay, so in other words, ar n minus 1 must be greater than 5 over 8192. So if I sub in the values of a and r, a is the first term which was 5 over 8, so 5 over 8, and then r is r half, okay, to the n minus 1. This must be greater than 5 over 8192. Then how can I solve this? Okay, first of all, I want to get rid of this part here, the 5 over 8. So it means I will write here a half to the n minus 1 greater than 5 over 8192 times, here are times by the inverse of 5 over 8, which is 8 over 5. Okay. Let's check it out with a clearer. So it means I will write here a 5 over 8192, okay, times by 5 by 8 over 5. Okay, I know the 5s will be cancelled, but just want to use it calculator here to give me. Okay, now the answer will be 1 over 1024. So this simply means that a half to the n minus 1 will be equal to 1 over 1024. So situation like this, always try to see if we can write this number here in terms of prime factor. What does it mean? Prime factor. It means I want to write it into its exponential form, having the base a prime number. Okay, so I'm gonna write 1024 and then press equal in the calculator, and then press shift and then press this button here, fact, and then this tells me what the number is in terms of the prime factor. So this will be equal to, so it's going to be like a half to the power of n minus 1 equal to 1 over 2 to the 10. Okay, so I want you to notice something. 1 over 2 to the 10. We can write also 1 to the power of 10 because 1 raised to the power, to any power is just 1. So why am I writing that? Because the property, one of the properties which I'm gonna write over here says a to the n over b to the n. One of says a to the n over b to the n equal to a over b, okay, to the n. So this is what I'm gonna apply here. This is just a half over n minus 1 equal to 1 over 2, okay, to the power of 10. Now, another property says when the bases are the same, okay, this implies that the exponent must also equal. When the bases are the same in an equation like this, a to the m equal to a to the n, this means that m equal n. So therefore, over here we say you can just drop the bases, so cross the bases, and then we will be left with n minus 1 equal to 10. Be careful here, it wasn't equal, it was greater than, not equal, greater than, greater than 10. So now, to find n, I move the negative 1 over becomes positive 1, and then n will be greater than 11. Okay. All right, that's question 2.2. Thank you.